All right, number 7, we want to find the domain of the function. So if you go back to problem number 1, there were 3 scenarios that we looked for. We looked for a fraction, we looked for a square root, and we looked for a logarithm. If neither of those 3 are present, then we call our domain all real. All right, so in this example, I put y, but f of x, same thing. They're interchangeable. But we want to use f of x since we're doing function notation. This is equal to negative 5x plus 4. Okay, so in this expression, we do not have a fraction. We do not have an even root, square root, radical. And we don't have a logarithm. So therefore, our domain is all real. So that means negative infinity to positive infinity. They want it listed in interval notation, and this is how you do all real in interval notation. So negative infinity to positive infinity. Alright, number 8, this time we have g of x, and they can use different letters, but it's still y equals, basically. Don't let that confuse you. So we have gx equals 3x divided by x squared minus 16. So that first scenario that we look out for, meaning a fraction, we do have a fraction. What we have to remember is that we cannot divide by 0. So to figure out our domain, we take the bottom and we say domain, whatever's on the bottom, which is x squared minus 16, this cannot equal 0. And then we solve for x. So you would add 16 to both sides. Then we bring down x squared cannot equal to positive 16. And then what numbers would make x squared positive 16? We have to square root both sides to figure that out. When you take the square root of a number, remember positive or negative. You have to add that. You got 2 cases. So we have x cannot equal positive or negative 4. So there's 2 numbers that we're dealing with. Now, we want to put this in interval notation. So we use a number line to help us see what's going on. And 0's in the middle, negative 4 would be over here. That's one possibility, and positive 4 here. And what we're going to do is we're going to remove these 2 numbers from the number line, which doing so will break your number line into 3 sections. So this is going to negative infinity. So we have the section from negative infinity all the way up right until we get close to negative 4. So like negative 3.999999, and then we get on the other side of negative 4, and we go all the way up to positive 4, or close as we can to it. So this is one section, this is another section, and then we jump on the other side of this, we have 4 to infinity. So it's kind of like taking your number line and breaking it into sections, because that number negative 4 is gone, and then you have this section, and then you have 4 is gone. And so your number line is broken into 3 strips, and so you have to identify those sections, and this is how you do so. And you connect those with unions. So you have negative infinity, close as you can to negative 4, union, other side of negative 4, close as you can to positive 4, and then union, and then positive 4 up to positive infinity. And so this is how you would write your domain in interval notation. So we have negative infinity up to negative 4, and then union, to positive 4, and then 4 up to infinity.